I'm going to speak about quality and safety assurance at a TID Radiation Test Laboratory. Okay, I don't want to be too much pessimistic from the beginning. We will come back later. I'm going to divide the presentation in two parts, quality assurance and safety assurance. The idea is to describe all the requirements specified in the test method. So I have grouped all of them in 9 different categories. We have no time to describe all the requirements, of course, but we will see the most interesting ones. I'm going to focus on the European test method, ESCC 22900, and a similar analysis could be done with the equivalent military method. Okay, the first category is about the radiation source and dosimetry. And of course, the radiation source have two mainly options. From one hand, we can decide to use a cobalt-60 radioactive source or an electron accelerator. In our case, we have used a cobalt-60 gamma source inside of a panoramic irradiator. The idea is to describe the requirements and also to put an example, and real example of our company, of course. About the dose, I want to emphasize the importance of the uniformity of the dose. Of course, the requirement is that the uniformity has to be more than 90%, or the same that the non-uniformity is less than 10%. And this is very important because you are irradiating on a lot of 11 test samples, for example, and you need to guarantee that the same dose is achieved for all of them. In our case, thanks to the collimator inside of the irradiator, we can guarantee a uniformity that is more than 99% in some cases, depending of the field size, of course. Another requirement is about the dose steps. When you need to perform multiple exposures, you have to choose where you are going to interrupt the radiation test to perform the electrical measurements. In this case, the test method is very easy to comply, but I would like to emphasize that it's very positive to show a flexibility in the schedule. In our case, we have experimented that, for example, for solar orbiter, we can change the dose rate during the test campaign in order to accommodate the dose levels agreed previously in the test plan to accommodate to the result obtained. So this approach allows us to reduce the timelines and to get a better knowledge of the behavior of the device. The dose rate is critical in this radiation test, of course, because allow us to calculate the dose that is achieved by the components submitted to radiation test. This dose rate has to be calibrated in a better than 5%, and what is very important is has to be constant within 10%. So in our case, we have implemented a RadLab monitoring system, a system to monitor the dose rate is 2 minutes. In such way, we can guarantee that the dose rate is constant during along the radiation test. And about the calibration, we can guarantee around 3.5% based on the calibration certificate. About the dosimetry is basic, the requirements specified by the test method, and it's easy to comply because you only have to choose a good calibration laboratory. In our case, since we are certified by ISO 70025, we choose always accredited laboratories to calibrate our dosimetry equipment. And now we are going to talk about temperature. We can divide the temperature during the radiation exposure, and the most interesting requirement is that the variation during the radiation has to be lower than 3 degrees. This requirement is not easy to comply if you are not in position of to have a good air conditioning system or a good monitoring of the humidity, pressure, and temperature during the radiation. It's not easy to keep the temperature in 3 degrees. In our case, we have implemented a monitoring system that allows us to see the trend of the temperature and to change the condition before to exceed the limits. The temperature is also required during the electrical measurements, but it's easy to comply if you have a controlled area in your laboratory. And another requirement is about the temperature during the transport from the irradiation room to the laboratory of the electrical measurements. The requirement is 10 degrees, and is easy to comply if you control how to transport the test samples. In our case, the transport duration is only 5 minutes, and we also have a calibrated carrying briefcase to transport them. Okay. The test samples. The first requirement on the test sample is how to place to submit to radiation test. Okay, it's very important to use filter box that is composed basically by lead and aluminum with a build-up cover to minimize the low energy scattered radiation contribution. And also, it's very important to keep the traceability to perform a serialization before starting the test, of course, because different electrical measurements are performed on the test samples, and it's very important to keep the traceability, as I said before. And also, it's necessary to use one control sample to gain confidence in the electrical measurement system. Okay? About the electrical measurement system, it's very important to guarantee the low levels of interference, the stability, accuracy, and resolution. But if you choose a good equipment to your measurement, and if you validate internally the software, you can comply with them. Where you are going to perform the electrical measurements? Of course, you can choose between remote or in situ testing. In both cases, you have to guarantee that the instruments are properly shielded with the accuracy needed. We are going to talk about the test circuit boards. Of course, it's the boards where you place the components when you are going to submit to radiation test. These boards have to implement the previously agreed circuits in the test plan. Sorry. The circuit is very important because there is a strong dependency of the circuit in the radiation results. The board has to guarantee the uniformity in all the samples, and the test circuit board has to be validated to minimize the noise, the leakage currents, and of course the good use of that. And last, for these text features, we can say that you always are going to need cabling, sockets, and switching system, and all of them have to be radiation tolerant, and you need to check periodically all of them to be sure that everything is good. In our case, we use always sockets and cabling that we have previously characterized, and we have included in a database with all the information about the radiation tolerance. The bias conditions are very important in the radiation test, of course, because we have observed that depending of the voltage applied on the components, normally the behavior is different. This voltage has to be constant during the test. And you have a 10% of tolerance to apply this voltage with respect to the test plan. What we do is to monitor the voltage and the current along the test. In such way, we can detect any variation in the current or in the voltage to change the configuration if necessary. The time is very important as well in the radiation test, because if you, when you are not irradiating the components, a recovery can be found. This recovery changes the results on the electrical measurements. For that, the test method specifies that you have to start the electrical measurement not later than 1 hour from you move the radiation samples from the irradiation room. In our case, it's easy to comply, and we normally start the measurement only 5 minutes after the radiation stop. We recommend to have always the same dedicated TID engineer for each lot, because you can control what time you need to perform the electrical measurements, because the second requirement is that you only have 2 hours to reanudate the radiation. About the documentation, there are no specific and difficult requirements, but we have to say that it's required a test plan that is approved before starting the test, and of course a final test report which contains all the graphs and results obtained during the test. In our case, we can offer that the report is sent even before to finish the radiation test. In that case, the user is informed about the behavior before to finish it. Okay. we can speak about more requirements not included in the test method, but I wanted to emphasize 3 of them. On the one hand, I think that it's very important to have a good quality system in the test laboratory with the proper checklists, internal checklists, and internal procedures to perform the radiation test in a good way. And also, the interlaboratory comparison is very important to share the information and to compare the results. In our case, we have performed interlaboratory comparison with ESA and UCL, and all the successful results were presented in the rec. And the other point that I would like to mention is the importance of the external and internal audits, if possible, to achieve accreditations. And in our case, we have the ISO 70025 accreditation for the TID test, and we are the only lab certified in Europe. And we have the DLA laboratory suitability to perform the radiation testing. That, of course, is very important for us as well. Now, we are going to change to speak about safety assurance. I wanted to, okay. I wanted to wrap it quickly, explain what happens if you want. We are going to think that you want to be irradiated in the irradiation room because you are not a very clever person. So what will happen if you tried it? Okay, in first place, you cannot enter in the control room if you have not the biometric fingerprint authorized. Second, you will need the keys to control the console that control the irradiator. If the irradiation is on, the console of the irradiator will show the indicators with signal, acoustic signal and light to advise you that the radiation is on. If not, if you don't see that, you will see the area monitor with the different light to advise you about the source position. If you don't see that, you can see what happened inside the radiation room through the camera that is installed and the monitor that is placed in the control room. If you don't see that, maybe you will see the other monitor. If you don't see that, maybe you will see the red lights above the door to enter in the radiation room. That is advising you that the radiation is on. If you don't see that and you try to enter, the system is connected to the area monitor in such way that you can enter if the radiation is on. But anyway, if you can enter, pushing manually, the open door sensor will move the radiation source to the safe position. But if not, if you finally achieve to enter in the radiation room, the motion sensors, 3 motion sensors, will stop the radiation. If you achieve enter, you will see a red indicator rod that is connected physically to the radiation source through the head of the irradiator, but maybe you don't see that. Maybe you will see you will see the red lights in the head of the radiator. If not, your personal active dosimeter with acoustic and visible alarms will advise you about the radiation. If not, if you don't hear it, keep calm. You will never enter alone. For our company, we have very strict procedures, and we always work in pairs. And if you are part of that, there are another safe precautions that can be explained in other moments. Anything that can go wrong will go wrong. Maybe yes, but if you aim high, even if you fail, you probably will meet the requirements. Thank you.